Every single time you feel thirsty, you're sure you know exactly what's going on. Your body has dried out and it's asking for water. But what if I told you that you can be completely full of water inside and still feel a desperate, burning thirst? And you can be almost dehydrated and feel no thirst at all. So if it isn't the missing water that switches thirst on, then what is it? The answer is hidden deep inside your brain, and it has far less to do with water than you imagine, and far more to do with something you sprinkle onto your food every single day. But before I show you what that is, let's put a name to the picture you have in your head, because almost everyone imagines exactly the same thing. Your cells are little pouches filled with water, and when you sweat, breathe, pee, that water leaves, so the cells slowly dry out and shrivel up like tiny plants, until at some point they cry for help. They send a warning to the brain, and that warning would be your thirst. It's a pretty image, it's intuitive, and you've probably felt it come to life on a hot day. The dry mouth, that urge to down a whole glass in one go. Everything seems to fit perfectly, and that's exactly why almost nobody suspects that this entire picture is wrong. Let me ask you a really simple question. If thirst were just your cells running out of water, why does eating salty fries make you thirsty almost instantly? Think about it with me. You didn't lose a single drop of water eating that portion. Quite the opposite. You only chewed. Your mouth was working. You didn't sweat at all. And yet, 10 minutes later, you're hunting for a glass of water in a hurry. If thirst were simply a lack of water, that just shouldn't happen. So stop everything. Because your brain isn't monitoring how much water you have, it's monitoring something completely different. And the salt in those fries messes directly with that thing. Thirst is not an alarm for out of water. Thirst is an alarm for salt. And here's the twist that changes everything. Your blood is basically water with salt dissolved in it. And what your body defends tooth and nail is not the amount of water. It's the ratio between the two, how salty that water is. It wants to keep that concentration always at the very same point. Never saltier, never more diluted. And now think about what happens when you lose water sweating or breathing. The water leaves, but the salt stays behind. So your blood doesn't end up short on water, it ends up saltier. And it's that change, the salt getting too concentrated, that your brain detects and turns into thirst. The water that vanished is just a side effect. But this raises an enormous question. How on earth can a brain sense how salty your blood is? And this is where it gets almost surreal. Because inside your brain, there's a tiny cluster of neurons with one very specific job. They measure the saltiness of your blood. They're like minuscule sensors dipped right into your bloodstream. And the way they work is beautiful in how simple it is. These neurons behave more or less like raisins. When the blood gets saltier, the salt pulls water out of those cells, and they shrivel, they shrink a little. And when you drink water and the blood dilutes again, they swell back up, and the brain reads exactly that. Shrunk means it's too salty, and so it fires off thirst. In other words, that shriveled little plant from the very beginning of our story really does exist. It's just not all of your cells. It's only these few sensor neurons, shrinking and swelling, working like the button that switches your thirst on. So notice the complete reversal here. You don't feel thirsty because your body dried out. You feel thirsty because one very specific little group of neurons shrank. But if these sensors are that precise, just how precise is this whole system, really? And brace yourself, because this number is jaw-dropping. Your body can detect a change of about 1% in the saltiness of your blood. 1%. A minuscule shift, almost nothing, and the alarm already goes off. Think of that air conditioning thermostat that kicks in on its own when the room warms up by just half a degree. It's the same idea, but far more sensitive still. Your brain has a salt thermostat running 24 hours a day without you ever noticing, always correcting, always adjusting. And it doesn't even have just one tool to fix this. It has two. The first one you already know well. It's thirst. It's the tool that depends on you doing something, getting up, grabbing the glass, drinking. But while you don't drink, Does the body just sit there with its arms crossed waiting? And the answer is no, absolutely not. Because the very moment the salt rises, at the same time it triggers thirst, the brain also releases a chemical messenger into the blood with a very clear order for your kidneys. Don't waste water. Hold on to everything you can. And that's exactly why when you're low on water, your pee turns darker and more concentrated. The kidneys are squeezing every last drop back inside, returning water to the blood instead of throwing it all away. And now you can see the full system working. The brain measures the salt, and if it went up, the brain does two things at once. It gives you thirst so you'll put water in, and it tells the kidneys to stop losing the water you already have. Offense and defense, both together, in the very same instant. So what you thought was a simple little in and out system is actually a whole orchestra, with a conductor obsessed with salt directing everything behind the scenes. And this is where we reach the most impressive part of all, because this conductor has a trick that seems to defy logic itself. Notice this the next time you drink water while dying of thirst. You raise the glass, you drink, and within just a few seconds, the thirst is gone. Seconds. And there's a giant problem hidden in that, because the water you just drank is still sitting there in your stomach. It's going to take a good 10, 15, 20 minutes to be absorbed and finally reach your blood and dilute that salt. So if thirst only switched off once the salt actually dropped, it should keep nagging you for another 20 minutes after you drink. And you'd end up drinking far more water than you need every single time. But that's not what happens. Thirst shuts off almost immediately. And the question is, how? How does it switch off before the water has even arrived? And the answer is chilling. Because your brain doesn't wait for the water to arrive, it predicts that it's going to arrive. There are neurons in your throat and in your mouth that basically count your gulps. As you swallow, they keep sending signals to the brain saying, "Relax, water's coming, we've already swallowed enough." And the brain, trusting that count, switches thirst off before the hydration has even really happened. It's a system of pure anticipation, a calculated guess. Your body bets that that amount of gulps will solve the problem, and it turns the alarm off based on the bet, not on the result. So pay attention to what this means. You don't drink until you're hydrated. You drink until your brain thinks you're going to be hydrated. And now come back with me to the very beginning. You thought you felt thirsty because your cells were dry, begging for water. Something simple, almost mechanical, a shriveling little plant. But now you know the truth. Thirst doesn't watch over your water, it watches over your salt. It's fired off by neurons that shrivel like raisins. It's measured with a precision of 1%. It's corrected by two armies at the same time. Your urge to drink and your kidneys saving every drop. And it's switched off by a brain that counts your gulps and predicts the future before it arrives. And all of this is happening right now, in silence, while you breathe, without you noticing a single thing. You only feel like having some water, and everything else is an invisible machine of absurd precision working behind the scenes. And that's where the most beautiful part of all lives. The most ordinary sensation you have, that dry mouth in the late afternoon, hides one of the most sophisticated control systems in your entire body. So the next time you tip back a glass of water, remember, it wasn't your cells that asked for it. It was a salt thermostat, deep inside your brain, betting on your next gulp. And if even thirst, something this simple, is all this complex on the inside, then just imagine what's hiding behind hunger. But that's already a story for another video.